Hey guys, today we're going to introduce and look at multiple point charges. When charges are placed on nonlinear locations, which means that you have two on the x-axis and one on the y-axis, you may no longer simply add or subtract these point charges. You must now treat your forces as vectors. That means we're going to split apart the individual directions and into our x and our y components. We're going to add all of our x's and add all of our y's and then use Pythagorean theorem. In order to do this, we are going to be using sine and cosine again. So these are going to become a little bit overwhelming of problems. All right, so we're going to look at another example that has two of our point charges on the x-axis and one on the y-axis. All right, so we're going to take a look at the second practice problem. Now notice, I have a triangle, and I have 3 point charges being arranged at the vertices of this triangle, as shown in the diagram on the left. We are going to try to calculate the magnitude and the direction of the electrostatic force acting on the third charge if charge A, which is here, has a value of -6 times 10 to the -6. Charge B, which is here, has a value of 4 times 10 to the -6. And charge C, which is here, has a value of 2 times 10 to the -6. So I'm going to write down some variables on this triangle before we even get started with the math. So the first thing, it says A is 4 meters. So I'm going to put 4 meters right there. It says B is 3 meters, so 3 meters is right there. If this is a 3 and a 4 meter right triangle, my hypotenuse is going to end up being 5 meters. Now I know that because I know math, but in order to find that, you can also calculate the hypotenuse using a squared plus b squared equals c squared. So it ends up being 5 meters. The second thing I want to calculate, so here I have my right triangle. Since this is the force that I'm going to be looking at, I want to find this angle right here. So in order to do that, I'm going to go up here and I'm going to do tan to the -1, which is inverse tangent of opposite over adjacent. That gives me a value of 53.1 degrees. So this is 53.1. Now that's going to come into play later, so I'm just adding it now so I don't have to really worry about doing the extra math later in the equation. So what we are trying to do is calculate the total force acting on this point charge. So first, I have to look at the force of A acting on C, okay? So I'm going to do force A on C is 8.99 times 10 to the 9 times 6 times 10 to the -6 times 2 times 10 to the -6, all over 5 squared. This value is 0.004315 newtons. Now, since I have a negative and a positive, this is an attractive force, meaning attractive. This force arrow is going to be going in this direction. It's trying to move towards QA, or the first charge. Okay, now I'm going to do the same thing for the force of B on C. 8.99 times 10 to the 9th, that's 4 times 10 to the -6 times 2 times 10 to the -6, all over 3 squared. And math that through, and I have a value of 0.00799 newtons. And since I have a positive and a positive charge, this is a repelling force, or a repulsive force. So that means that I'm going to draw another arrow here. This is going to go in this direction. So when I compare or combine these forces, I'm actually going to be subtracting the x directions because of the fact that one's going positive or pushing away and one's pulling towards. Okay, so now I have these two total forces. So I have this yellow line and I have this blue line. The issue is I cannot add these because this yellow line is not in the x and the y direction. So what I can do is solve for the x component and the y component like we used to do in force problems. So if I write down FACX and FACY, I'm going to use sine and cosine to separate out that hypotenuse of the triangle. So we're going to use the same relationship as in our kinematics unit. We're going to use the hypotenuse, which is 0.004315, times cosine 53.1, because that's the theta that we found, and that'll give us the x component of the force, and that's 0.00259. But this is in the negative direction. It's going back towards the origin. Then we're going to do the same thing, 0.004315 times sine 53.1, and that's going to give us the y direction, which is 0.00345, and that is in the positive direction, or going up the y-axis. Okay, so now we have to find the total x and the total y. If I look at this blue arrow, all of it is in the x direction. So I'm going to use FBCX is that whole number, 0.00799, and that is in the positive direction. So now I'm going to do FX total equals, this is in the negative, this is in the positive. So I'm actually going to subtract those two numbers. Okay? So 0.00799 minus 0.00259, and that gives us a value of 0.00539. F in the y direction, there's only one, so it's 0.00345. Okay, so these are the two values that we are going to use for our last two steps. We have the x component and we have the y component. Now we have to combine them using Pythagorean Theorem. So I'm actually going to clear off this screen so I have a little bit more room to work, but I hope you have all of this written down in your notes. Okay, so I'm going to clear off the screen. We have, I'm going to rewrite fx is 0.00539 and fy is 0.00345. So we're going this way and this way because the x component in the positive direction was larger. So we have to solve for the hypotenuse and we have to solve for this angle. So hypotenuse, we have a squared plus b squared equals c squared. 0.00539 squared plus 0.00345 squared equals c squared. Square both of those, and they're going to be really small decimals, so I'm actually going to skip that step just because it's a lot of writing. And then I'm going to square root both sides once I add them together, and c is a value of 0.00639 newtons. So that hypotenuse, this blue line, is 0.00639 newtons. Now I have to do inverse tangent of opposite, which is our y direction, over adjacent, which is our x direction. So 0.00345 over 0.00539. And once we put that into the calculator to solve for our theta value is 32.6 degrees. So our total answer, our final goal, 0.00639 newtons of force is felt at 32.6 degrees on the third point charge at this location. Okay, so that was kind of a doozy. We did a lot of work to solve for that total force. Now I can add 4 charges, we could have 5 charges, we could have infinite amount of point charges acting at this location. We could have infinite amount of point charges acting together, and we would have to then find the x's, find the y's, combine the x's, combine the y's, Pythag inverse tan. So we've done this before in class. It's just a matter of now putting it towards electrical charges with the electrical equation instead of doing just vectors and just speeds and velocities. So when we get to class, we're going to practice how to interpret and solve for unknown variables when it comes to using multiple point charges, whether they're all on the same axis or at different points in 2D dimensions. We will look at both. So I'll see you then so we can talk things over and hopefully work through some problems.